Hello everybody, it's jiaozai. Welcome back. And here's an item from geometry. Credits to the Art of Problem Solving community for providing me with this item. Triangle ABC has a right angle at C, and D is the foot of the altitude from C to AB. Points L, M, and N are the midpoints of segments AD, DC, and CD respectively. If CL equals 7 and BM equals 12, compute BN squared. As usual, pause this video and give this item a try. And if you're done, let us dive into the solution. Now, there's a lot of right triangles in the given. Actually, triangle ABC is one. There's a lot of right angles involved. So let us try to get relationships from the given lengths CL. We have CLBM, and then the value that we're asked for, BN. Now, let's highlight the three right triangles that involves those three given lengths. So we have the red triangle, denoted by 1, the blue triangle, denoted by 2, and the orange triangle, denoted by 3. And we have three equations, all from the Pythagorean theorem. Equation 1, CD squared plus LD squared equals CL squared. Now CL equals 7 from the given, so the 49 here is actually CL squared. Now for the second equation, in the blue triangle, MD squared plus DB squared equals BM squared. Now BM is given to be 12 in the item, so 12 squared is indeed 124, so this is actually BM squared. And for the last triangle, the orange triangle, BN squared equals CN squared plus BC squared. So from these three right triangles, we're able to get three equations just from the Pythagorean theorem. Now, there's actually one segment in particular that is very interesting, and it's this segment LM. Now, simply because LM here, L and M are midpoints of segments AD and CD respectively. Now, since N is also the midpoint of AC, we know that the length of LM equals length of NC, and LM is part of a right triangle, triangle LDM. It's the hypotenuse of it, so there's a lot of potential in LM. So in some items involving lengths or all geometry for items in general, it's very important for us to see or try to draw auxiliary lines, or try to just connect some points and make some lines, make some like in this case, let's connect LM and see what we can get. In fact, this will lead us to very, very amazing results. So let's see here. So let's connect L and M again. Now I have removed the three triangles, the three colored triangles, and in fact, we can find that these two are true. Now, the second equation, LM equals NC, was already proven, since LM is 1/2 of AC, because L and M are midpoints, and in fact, LM is called the midline of triangle ACD. So we know that LM is 1/2 of AC. Let me put this here. LM equals 1/2 of AC. Now, since N is the midpoint of AC, we know that NC is 1/2 of AC. So we have LM equals NC. So the second equation is done. Now, the first equation is via the Pythagorean theorem. LM squared equals MD squared plus LD squared. Now, this is very interesting since MD squared is part of the second equation, LD squared is part of the first equation. Now, this gives us two terms here, CD squared and DB squared. Now, let's talk about CD squared and DB squared. Now, they're part of the same right triangle involving the hypotenuse BC. So in fact, by the Pythagorean theorem, we know that CD squared plus DB squared equals BC squared. So this motivates us to see what will happen if we add equations 1 and 2, since we have quite a lot of information involving this, and we have right triangles to further give us the motivation to do so. So let's try to do that. So adding equations 1 and 2, we are going to get that 193 equals lm squared plus bc squared. Why? The 193 comes from 49 and 144. Now lm squared came from ld squared and md squared from this equation. bc squared came from the cd squared plus db squared, as shown in the previous slide. So we have lm squared equals bc squared. Now we have lm equals cn, so lm here can be replaced by cn. Oh, correction over here. This should be 193. So since lm can be rewritten as cn, we have 193 equals cn squared plus bc squared. And what do you know? Cn squared plus bc squared is indeed bn squared. So we simply replace cn squared plus bc squared by bn squared, and we have successfully arrived at our answer. Again, correction again, this should be 193. So we have bn squared equals 193.